All right, in 4.3, we're going to look at this thing called the coefficient of determination. It's this thing called r squared, which you may or may not have seen on your calculator so far. This section is going to tell us how good our lines are, not just what the line is. So let's look at Ford Mustangs. And we're going to look at, let's see, we have 12 of them. We have their age as my x value. So that'll be horizontal. And then we have the price as the y value in hundreds of dollars. So hundreds of dollars means 256 times 100, which is actually 25600. So it's really 25,600. So let's go ahead and do regression, and then we're going to figure out some new stuff. Oops, I already did it. Ignore that. So go to stat, enter the data. And then you're going to go down to that linear regression, a plus bx, and then remember to tell it to look at L1 and L2. And you get what's above. If you don't have r and r squared, we're going to turn those on in a second, so don't freak out. But you do need those in a second. So let's just round at the same time. So let's look at our y values to figure out rounding. So my y values currently have 0 decimal places because there's nothing after the decimal, and they have 3 digits. So that means we need one more of everything. So my y-intercept needs one more decimal place, so 293.2. Instead of 0, we add 1, and so we need 1 decimal place. And then the slope is digits. So we need 4 digits, 1 more than 3. Since it's a negative slope, we can subtract 25.59. And then we will go ahead and not forget the x, and that is our regression equation. If you can see r and r squared on your calculator, great. You don't have to do anything. If you do not have those, I'm gonna tell you how to turn them on. You only have to turn them on once, and then you don't have to go through this process again. So what you're gonna do is you're gonna hit the button that says catalog, which is at the bottom. It's second 0. And then you just scroll. You have to hit the arrows until you have to hit the arrows a lot until you get down to diagnostic on. And then hit enter at diagnostic on, hit enter again until it says done. And then if you do regression again, r and r squared will be there. And if not, just send me a quick email or message and I'll help you get it turned on. And you never have to do this again, so it should be on. Cool. So we're going to look at those in a second. This section, we're looking at r squared, and then we'll do r in the last section. Cool. So let's look at where they're coming from, and then we will interpret them. So a big question we might have when we're doing regression is, was it actually helpful, right? Was it useful to do regression? So what I put on the right side is I did this, the regression equation. This is for the Mustangs. I graphed it. It's the red line. And then I found the square errors that we were talking about last section. So let's fill those all in red. So we're going to look at the sum of the square errors in a second. Remember, less area, less squares, smaller squares is good. But could we have just neglected age and just found the average cost instead? So that's this equation on the right. That's average cost. Right? Like in chapter 3, we didn't have a second variable. We just found average. So we're going to compare the square errors for average to the square errors for regression. So to me, it looks useful. Notice the one on the right, those square errors are definitely smaller than the square errors on the left. But if there's not much of a difference, then maybe regression's not worth the effort. So let's check out the formula. We're not going to use it, but it'll explain what's going on. So what the formula is doing is it's finding the sum of the square errors from the average. So I'm highlighting it in blue because it represents all of these squares. And then we find the difference between these squares on the right. So we're basically finding how much does it change by. Remove square error is the difference, right? How much error did we remove? And then we just divide it by the original squared error, which is the blue one. So it's basically like a percent reduction or a percent decrease, if you ever did these in algebra. But the calculator gave us that number, so we're going to focus on interpreting it, right? We don't need to know how to do these crazy formulas. We need to know how to interpret things.